Example 2.3.3. A clothing manufacturer determines that the cost in dollars of producing X jackets is closely modeled by the function C of X equals 950 plus 25 times the square root of X. Find each of the following. A. The average cost per unit at a production level of 100 and at 400 jackets. Let's first get the average cost function. The average function is defined as the function divided by X. So we will write the cost function, which is 950, plus 25 times the square root of X, all divided by X. That is our average cost function. So now let's compute it. We can also use C bar at 100. That would be 950 plus 25 times the square root of 100 divided by 100. That will simplify to 950 plus 25 times 10 divided by 100. So that will be, let's see, 950 plus 250 is 1200 divided by 100, which is 12. Do the same thing. Average cost at 400, that will be 950 plus 25 times the square root of 400, all divided by 400. Use your calculator to compute this, and the result is 3.625. Part B. The marginal average cost per unit at a production level of 100 and at 400 jackets. To find the marginal average cost, we're actually going to have to compute the derivative. So let's begin with the average cost function we computed for part A. That is, average cost is equal to 950 plus 25, and instead of writing the square root of X, I'm going to write X to the 1/2 divided by X. Then we will use some algebra and simplify this to 950 divided by X plus 25 times X to the 1/2 divided by X. And then we can write this as 950 X to the minus 1 plus 25 times X to the 1/2 in the numerator minus 1 would be minus 1/2. Now we can readily take the derivative of this function, so we'll do C bar prime is equal to, then we'll have 950 times the derivative of X to the minus 1 would be minus 1 X to the minus 2, then plus 25 times the derivative of X to the negative 1/2, we bring the negative 1/2 down, X to the negative 1/2 minus 1 would be minus 3/2. We can clean this up a little bit and rewrite it as, let's see, 950, let's put the negative in front of it, over X squared minus 25 over 2. And then I'm going to go ahead and just write this as X to the minus 1/2. We can compute the values using your calculator. So in your calculator, compute the derivative C bar prime at 100, and you'll get negative 0.1075. And in your calculator, compute the marginal average cost, that's C bar prime, at 400, and that will give you negative 0.0075. Part C. The estimate of the average cost per jacket when 101 and 401 jackets are produced. So we say C bar 101 is approximately the average cost of making 100 of these jackets plus the rate of change, that's C bar prime, of making 100. So this would be 12 plus negative 0.1075, which gives us 11.8925. I would approximate that to say maybe $11.89. And now let's do the same thing for C bar. That's the average cost of making the 400 first is approximately the average cost of making 400 plus the average cost's rate of change of making 400 jackets. So that would be 3.625 plus negative 0.0075. We get 3.6175, and let's round that to $3.62. Example 2.3.5. Consider the cost function given by C of x equals 20,000 plus 980x minus x squared for x that is equal to or greater than 0 and less than 1,000, and C of x equals 0 for x equal to or greater than 1,000 with C of x in dollars. It is shown that C prime at 110, that's the derivative of the cost function evaluated at 110, is 760. What is the correct interpretation of this result? The correct interpretation: at a production rate of 110 units, the cost of production per unit is $760. Example 2.3.6. Consider the cost function given by C of x equals 250,000 plus 15,000x minus 0.3x cubed, where x is the quantity of laptops produced per month and C is in dollars. Find and interpret the marginal cost at a production level of 500 laptops. Solution: for the function C of x equals 250,000 plus 15,000x minus 0.3x cubed, the marginal cost function C prime of x, which is just the derivative, is the derivative of 250,000, the constant is 0. The derivative of the next term, 15,000 times x, is 15,000 minus, and the derivative of 0.3 times x cubed, we bring down the 3 and multiply it to the 0.3. That'll give us 0.9x, and 3 minus 1 is 2. So if we evaluate at 500, we take the derivative of the cost function, which is the marginal cost function, and put 500 in. Every place there is an x. You get 15,000 minus 0.9 times 500 squared. Compute that, and the outcome is negative 210,000. The interpretation: this suggests that at a production level of 500 per month, the total costs are decreasing at a rate of $210,000 per month. Critical thinking analysis. The math was done correctly. Even so, the result suggests that this cost function is unlikely, as costs typically increase as production is increased. Example 2.3.7. Consider the revenue function defined by R of x equals the quantity 100 times e to the power of 0.3x, all divided by the quantity 2 plus x for x equal to or greater than 0. For which range of x values is the marginal revenue negative? Please see completed example in your lesson notes. Example 2.3.8. For the cost function defined as C of x equals negative x cubed plus 6x squared minus 7x for x equal to or greater than 0. Determine the maximum value of C average. So, to proceed with this problem, we must first find the average cost function. C average. We also use the notation C bar of x, and we compute that as the cost function divided by x. The cost function is negative x cubed plus 6x squared minus 7x divided by x. Let's do a term-by-term division of each of the terms. Then we get negative x squared. We lose one power because we're dividing by a singular x, plus 6x minus 7. Now we see that the average cost function, which is negative x squared plus 6x minus 7, that gives a graph of a parabola that opens down. It's a parabola that's upside down. Now, in order to find the max or minimum, we need to find out this vertex point. Now let's observe that at this high-end vertex point, you have a tangent line, and the tangent line has a slope of 0. So, to find this maximum location, we need to find the derivative of the average cost and set it equal to 0. Let's do that. The derivative of the average cost function is negative 2x plus 6. I just took the derivative of negative x squared plus 6x minus 7. Now let's set that derivative equal to 0. 0 is equal to negative 2x plus 6. And so when we solve for x, we get that x equals 3. Now, the question said determine the value. X gives you the location. So this is the location of the max. But what we want is the value of the maximum. And to do that, we evaluate x equals 3 in the average cost function. That is, we will compute, not in the derivative, but in the actual average cost, C bar, at 3, which will be negative 3 squared plus 6 times 3 minus 7, and that is 2. The maximum average cost is $2. Example 2.3.9. For the cost function, C of x equals 5,000 plus 20x minus 1/2 x squared in dollars, find the following. A, the marginal average cost. Remember, marginal always means take the derivative, so we got to first find the average cost, and then we'll compute at x equals 20. The average cost function is the cost function divided by x. So we will have 5,000 plus 20x minus 1/2 x squared, all divided by x. Let's do term by term division. Then you will have 5,000 divided by x is the same thing as 5,000 times x to the minus 1, plus 20x divided by x, the x's cancel. Then we still have minus 1/2 x squared divided by x leaves 1x. Now that we have the average cost function, we can now compute the average cost function's derivative, which is the marginal average cost. So let's find that. The derivative of 5,000 x to the minus 1 is minus 5,000 x to the minus 2. The derivative of 20 is just 0, and the derivative of negative 1/2 x is negative 1/2. Let's evaluate this at 20. So we have C bar prime. That's marginal average cost evaluated at x equals 20. That's minus 5,000 divided by 20 squared minus 1/2. When you compute that, you will get negative 13. Part B. Use the result from Part A to estimate the average cost when x equals 21. So in order to estimate the average cost at 21, so we're going to use squiggly estimate, okay? We're going to need the average cost at 20, and we'll need to add to that the marginal average cost at 20. Now, that means we have to compute the average cost at 20. We haven't previously done that. So C bar 20 is equal to 5,000 plus 20 times 20 minus 1/2 of 20 squared. Remember to divide by 20 and then use your calculator to compute, and you'll get 5,200 divided by 20, which is 260. The average cost when x equals 21, we will evaluate that to be 260 plus, and then we had minus 13 for the rate of change. So using these two values, we get that the average cost estimate for the 21st item is about $247.